Hi and welcome to this section where we are going to start our study of some of these iterative techniques. So today we shall look at numerical iteration methods, some of these numerical iteration methods. Brief introductory remarks. We say that a numerical iteration method, or simply an iteration method, is a mathematical procedure that generates a sequence of improving approximate solutions for a class of problems. So we okay, I'll just put down that all we seek to do is to improve on the approximate solutions. Okay, to improve on the approximate solutions. How do we do this? We start with maybe a solution x1, which is not very good. Then we get the next solution x2, which is an improvement to x1. Then we get the next solution, and so on until we reach a point which is going to be determined by a termination criteria. Okay, now this termination criteria can be based on maybe accuracy, okay, accuracy, or we can give it another name which we want to call tolerance, okay, or it can be based on the number of iterations which we want. Maybe we can say that we are going to try to improve on our solution like maybe 4 times, and after that we stop, okay. Or we can say that we are going to improve on our solutions until we hit a desired level of accuracy. So this specific way of implementing an iteration method, including what we have mentioned, the termination criteria, is called an algorithm. It is called an algorithm. Okay, this is a specific way. Now, since this, you will see that this algorithm simply involves a procedure which is repeated many times. Okay, it involves a procedure which is repeated many times, and therefore in real world, in the real practice, we can always use the help of computing power to help us with these solutions here. So some of these iterative methods which we shall look at here include the basic ones. We shall start with maybe the bisection method. Okay, we have the bisection method, then we have the regular falsy method, and then we have also, maybe we shall also look at the famous, the Newton-Raphson method. Okay, now some of these involve us getting an initial guess. Okay, we have an initial guess, and then we use that initial guess, maybe we can call it x naught, and then we use that initial guess to get maybe the next approximation x1, and so on until what we said, our termination criteria. Some involve what we call bracketing. We can be given an interval in which this solution is contained, and then we try to look within that interval. Maybe we have an interval AB, and then we try to look within that interval for the solution. Okay, sometimes oh yeah, this is important. Then some of these numerical methods, okay, if it leads us to a specific solution, then that method is convergent. Okay, it converges to a solution. If it does not, then it diverges. Okay, yeah, all right. Otherwise the method is divergent. Okay, now for this we are going to mainly look at polynomials, we are going to look at either polynomials, or we shall look at transcendental functions. So the functions we are going to look at are going to be of the form f of x equals to 0, for which we are going to we want to find the root of that function, okay, f of x equals to 0, where our f of x is either going to be a polynomial, e.g. we are going to have polynomials, e.g. you could write something like anything, maybe 7x squared plus x minus 8 or something of that sort, or it is going to be a function which involves trigonometric, okay, exponential, or logarithmic functions, okay, anything which involve a trigonometric, exponential, or logarithmic function, okay, anything of that sort. That is what we are going to deal with for this work of ours here. So what else do we need to have in these remarks? What else have I forgotten? Okay, in trying to work out this, we are trying to find the zeros of this equation, which I've mentioned here that it is going to be our root finding, okay, and then we are going to apply some of these methods. So we'll start with the bisection method. Pretty simple, just to illustrate this, okay. And yep, oh, I forgot something. No, let us start. I forgot to include this. We have the bisection, but we are going to start with fixed point. I think it's the most basic one, okay. Let's start with the fixed point. So what better way to start with this or explain this? We can always do this with the help of an example. So let me look for a suitable example here, or rather let us maybe first write down the procedure for this fixed point, okay.